Hey y'all, it's Miss A. Today we're going to be looking at some data representations. We're kind of going to look at a little bit of everything. It's kind of just a mixture today. Our biggest focus is going to be like these percent bar graphs. That's going to be majority of your assignment today. Just getting used to how those work. And then we're going to review some histograms, some bar graphs, and stem and leaf plot. All right, so let's go ahead and get started. It said, on Saturday, Kai gave his guinea pig 80 grams of food. The table shows the amount of each type of food he gave to the guinea pig. So we have these 4 different types of food right here, and then the amount in grams, and then represented on the graph with these different colors. I know it's kind of hard to see here, but they get darker. So this is white, gray, a little bit darker gray, and then darkest gray. It's kind of hard to see here. A little bit easier to see on my part. Looks kind of hard on the screen, but of course if this was given to you in front of you, it'd be a lot easier to read. So let's go ahead and get started. We already know that there was a total of 80 grams. I could find that by adding them all together, but the problem did tell me right here. All right, and it says which percent bar graph best represents the data. All right, so first thing we need to recognize is when we're talking about an entire group of data, the total, even though it adds up to 80, the percentages is still going to total 100%, no matter what, because it's the total, it's everything. So here, when you notice on F, the bar graph only stops at 80, that cannot be correct because we have to be 100% for all 4 categories or the types of food. So we can immediately eliminate F because it doesn't take up the 100%. All right, the next thing that you should look for is the fact that they gave me hay is 40 grams, and they went from the white one, which is hay, and said it's 40%. It's not going to match because 40% is always out of 100. This was not out of 100 grams. So they're not going to just take these numbers and put a percent sign with it and be done. So that should be a red flag there to eliminate that one. Also, the fact that you see here, for H and J, both of these sections are exactly the same. When you see 2 answer choices that begin exactly, they're both 50% for one category, in this case, it's probably going to be down between those 2 answer choices because they're going to give you 2 that are similar and you have to figure out which one is 100% correct. All right, so we know, without having to do any work, we know that hay is 40 out of 80, sorry, trying to focus here, 40 out of 80, and that makes sense. 40 out of 80 is 1/2, and 1/2 is 50% of the data, so that's correct. So that does make sense. Now the only thing left I have to do is figure out what this section is. Is it equivalent to 20 here, or is it going to be 10, 25%? So we have to figure out if this section, which is the alfalfa pellets, 20, is 20 out of 80. What is that as a percentage? Is it equal to 20% because it goes from 50 to 70, or is it 25% because it goes from 50 to 75? All right, I'm going to reduce that, and then we get 2 over 8. 2 over 8 can be simplified again by 2, and I get 1 over 4. And I know that that is a benchmark fraction, 1/4, and 1/4 is equal to 25%. 25%, which is answer choice J. Now we also could have used a little bit of thinking here. If you notice that 20 is half of 40, so whatever percentage this is has to be half of what the percentage for hay. So if hay was 50%, we knew that already, half of 50 is 25. So it makes sense that our correct answer was J. We don't even have to worry about these 2 because we proved that that these 2 are correct. All right, remember guys, 1/2 is 50%. Y'all got to know these. 1/2 is 50, and then 1/4 is 25%. Those are 2 common ones you need to know. All right, the next one here, we have Shaymar bought a bag of marbles. He took the marbles out of the bag one at a time. He recorded the color of each marble in the tally chart. So here are the different tallies for each color. I'm going to write them here beside it. So that's 5, 10, 15, 10, 12, 5, and 8. All right, so now we want to see, it says in which table do the percentages represent the relative frequency of these marble colors? The first thing I want you to recognize is the fact that these numbers here match these numbers here exactly. I've told y'all before, don't pick the ones that match from the problem. That's not going to be the correct answer. Unless there were 100 marbles in this bag, which I don't believe that adds up to 100. But if there were 100, then we'd be good. That would be 15% and so on. But it's not going to be that percentage because there's not even close to 100 here. We can add those up. We get, that's 10, so 20, 2, 3, 4, 5, and 50. So there's only 50 marbles, not 100. So we can eliminate A because it does not add up to 100%. If we were to add that up, it'd only be 50%. So like I said earlier, the total, because it's everything, has to equal 100. So let's see if we can eliminate anything from that. Add those up. 6 and 4 make 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 100%. So that could be it. Here we get 10 plus 9 is 9. 10 plus 9 is 19. And then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 169%. That can't be correct because it can't be more than the whole of 100%. And then here we get 10. 3, 4, 5, 6, 7, 8, 9, 10. All right, so these two equal 100%. So these are what I'm down between. The only two that total up to 100%. Now let's see if we can reason our way through this without having to figure out what is 15 out of 50 is what percent. Let's see if we can use some reasoning here. So we know that the color that appeared the most was black. It had 15 compared to the other ones were all lower than that. So 15 or black has to have the highest percentage. If it has the highest number of marbles, that means the percentage has to be the highest for that same color. So here's black. It says 10. Everything else is actually above it. So that's actually the lowest percentage, not the highest. It's the highest number, so it has to be the highest percent. Down here, black is 30. Everything else is beneath it, so that is the correct answer. We could prove it if we wanted to. 15 out of 50, I could simplify that fraction by 5, reduce it. We get 3 over 10, and then I know that 3/10 is 0.3 or 30%. You could just typo that to make it a decimal, and then Dr. Pepper it, move it twice to get 30%. So that is the correct answer, D. So a lot of times I've noticed on these questions, you can eliminate things, 1, by not equaling 100, and 2, by just using some common sense. If this is the biggest number, then that percent has to be the biggest. If this is the smallest number, then that's a percentage has to be the smallest. So just use a little bit of reasoning when it comes to some of those questions. All right, here we have a bar graph and then a histogram we're going to look at. It says employees who have returned from a company placed on different benefit categories. The bar graph shows the percentages of the retired employees in different benefit categories. Which statement about the employees is supported by the data in the bar graph? All right, so the first thing I'm going to do is, I know I've got a bar graph here. I need to figure out what these numbers are. So this is between 40 and 50, so that's 45. This is between 10 and 20, so that's 15. We get 30, and then we get 10. I'm going to go ahead and add them together. So that is 40. That is, what, 10, 4, so 60, 100. Wow. You don't see 100 as a total very often. Not in the 6th grade. All right, so I went ahead and added up to figure out how many there were altogether. Anytime you have a bar graph, or histogram, I would definitely suggest y'all to do that. So we know that there are 100 people total in this bar graph. All right, so it says we want to know which statement is supported. So that means it's true. Which statement is true? More than half of the employees are in category 1. So here's my total. More than half would be 50 and plus, 50 or more. Category 1 has 45. That's not 50 plus, so that is a false statement. It's not supported. All right, the number of employees in category 2 is twice the number, so that means more than, twice, double, than employees in category 3. So 2 is twice 3. 2 is more than 3. 2 is not more than 3. 15 is not more than 30. So that's not supported. C, the number of employees in category 2 or 3. So it can be this one or this one. So altogether that is 45. Need that number. is greater than the number of employees in category 1. So these two together is greater than 1. No, they're equal. That's not true. And then hopefully D is right unless we did something wrong. The number of the number of employees in category 1 is 3 times the number of employees in category 2. So this is 3 times the number in category 2. So we need to take the number of category 2 and multiply it by 3 and see if it gets me category 1. So category 2 is 15 times 3 gets me 45, and 45 is the exact number here, so that is correct. That is correct. All right, the next one. This histogram is actually kind of hard to read. I don't like these lines in the middle. I went ahead and figured out what each of them were. It's kind of hard to see, especially when you're looking at a screen trying to figure out what line that is. So this is 5. This was 10. I just had to look over and count the spaces on some of these. This is 20, 10, 14, because just like before, I told you whenever you have a bar graph or a histogram, definitely figure out the totals of each bar. All right, let's add all those up so we have those out of the way. So that's 20, 30, 40. This gets me 19. That's 7 and then 8. So add those up. We get 16 plus 8 is 24. And then 4, 5, 6, 7, 74. Don't know if I necessarily need that, but I might need it at some point. All right, so here we go. Based on this histogram, which statement is true? And I hope I did that right. I did it really quickly. Hopefully I did it correct. Let me double check. I'm second guessing myself at this point. I didn't do it to begin. So we got 15 plus 30 plus 17 plus 12. Oh, yep, I got it. Okay. Making sure. Based on the histogram, which statement is true? There were 15 swimmers who were younger than 30. So younger than 30. Here's 30. Here's younger than 30. Is not 30, but everyone below. That's 10 and 5 make 15. There were 15 who were younger than 30. That looks like it could be true, but you never want to go with the first one without checking the rest. A total of 10 swimmers were 50 years or older. Here's 50 and older. 8 and 4 make 12. That's not 10, so that's wrong. The number of swimmers who were 40 years or older is less than the number who were 29 and younger. So 40 and older. Here's 40 and older right here. So altogether that is what? 17 and 12. So 29. So that is less than the number who were 29 and younger. So this has to be less than 29 and younger. Here's 29 and younger, that's 15. Nope, 29 is more, so that's false. A total of 70 swimmers participated in the competition. Oh, we already did that. Total was 74, not 70. So that is incorrect. So the correct answer was A. So it does help. It saved us a little bit of time there at the end by doing that to begin with. All right, we're almost done. We have 2 more we're going to look at really quickly. I know this is a long one. Here we have a stem and leaf plot. The total number of items sold by each student who participated in a fundraiser is shown in the stem and leaf plot. Which statement is best supported by the data in the stem and leaf plot? Remember, whenever we are reading this, very important to read your key. We know that 1 and 2 means 12. So we've got 12, 15, 15, 15, 18. That's how we read it. These are my 20s, 30s, and 40s. Which statement is best supported by the data in the stem and leaf plot? F. The number of students who sold between 10 and 20, so 10 up to 20, so that wouldn't be including this this row just here. That's 1, 2, 3, 4, 5. That's 5. Is greater than the number who sold more than 40. So more than 40 would be 41, 2, so 1, 2, 3, 4, 5, 6. So it's saying this 5 is greater than 6. That's incorrect. Which statement is supported? So we want a true statement. All right, the number of students who sold more than 30. Here's more, so more than 30, not 30, has to be more than 30. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is greater than the number who sold fewer than 30. So fewer than 30 would be these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10 is greater than the number who sold, 10 is greater than 11? No, that's false. Sorry, had to read it again. So by figuring out what these numbers were, what 30 items or greater was equal to, it was 10 people or 10 items. This was 11. We take out all those words and we can focus on just the numbers. 10 is greater than 11. That's not true. 5 is greater than 6. That's not true. Just kind of helps to read it without all those words there. All right, H, the most common number of items sold was 30. All right, so 30 appeared twice, but also 31 appeared twice, and 48 appeared twice, and 49 appeared twice, so that's not true. And the most common number sold is 15. 15 actually appeared 3 times. Nothing else. That's 2, 2, 2, 2, 2. Yeah, so that was the most common one. It appeared 3 times compared to the other ones that appeared twice. All right, and then the last one is another histogram. This was actually on your practice test y'all took last week. Very easy question. Hopefully y'all got it right. The table shows the number of photocopies made during one day at each of the 25 schools in the school district, which histogram displays all the data in the table correctly. Now, one thing that was very nice about this problem is that it gave me in a table and they're already in order for me. I don't have to worry about putting them in order. They're already done that part for me. Which histogram displays the data in the table correctly? Notice we've got the same exact intervals down here for every single thing. So all I gotta do is focus on one and be done. I don't think this is going to be correct. I don't think they're all going to be equal, but let's go ahead and figure it out. So if my first one is 800 to 899, so basically all the numbers in the 800s. So that's these numbers right here, because this gets bigger. So that's 3. So that goes to 5. No, that's definitely not right. This goes to 3. That one does work. This one goes to 3. That one works. This one only goes to 2, so that one doesn't work. So we eliminated D. All right, next one is my 900s. So 900s were this one. No, wait, I'm going to skip that one because look here. Notice here for my 900s, it goes to 5, and this one also goes to 5. So it's literally pointless to do that because the 2 that I have left are the exact same. I just need to focus on my numbers that are in the thousands right here because this is 7, and this one is 8. So we're looking for 1,000 to 1,099, or just below 1,100. All right, so 1,000. That one is this one. Cross those off because I don't need those anymore. This one. We're stopping at 99. So 56, 85, 94, 98, and that one's a little bit too big. All right, so the numbers that fall in that range, there were 1, 2, 3, 4, 5, 6, 7, and 8. So the correct answer was C. So that's how we do the histogram. Histograms are one of the easiest ones we do. All right, guys, I apologize. I know this video was super duper long. Hopefully it cleared some things up, especially for those beginning questions with the percent bar. Y'all have got a Google form to work on today that is only 5 questions, so please join me on Zoom and we can talk through those problems together if we need to. Y'all have a great day, and I will talk to y'all later. Bye, guys.